All right, good morning, everyone. It's great to be here again. I think that sharing these projects are a great opportunity to share the work we've been doing through the BMP program. So thank you, Lakesh, for making this an opportunity. This is the second year that I've received funding for this project. This is a commercial sod farm in the Tri-County area, and we have been incorporating compost, different rates of compost on the sod farms. Used about 12 acres of the sod farm to do that. Census of Agriculture says that we have increased sod farming acreage in Florida from 2017 to 2022, and that was only by a slight amount of acreage, as you can see, but the financial implications were pretty significant, nearly 200 million more in terms of products sold. And in our area, in the Tri-County area, we apply compost as a top dressing to our sod farms, about 3,000 acres of sod farm. And from our first year, this was what we started in year one, was just strictly a demonstration trial where we used two different types of compost, or commercial compost, live soils and Indian head, and we applied at different rates on 1 acre parcels. And so we applied 0, 2, 4, 6, 8, 10 tons per acre. And we did that for live soils parcels and also for Indian head. We looked at nutrient potential, soil moisture. We collected soil samples and tissue samples and did soil moisture sensors and took soil health parameters and evaluated those. The second year, what's really significant here is that we conducted replicated field trials, and we isolated the compost rates on those replicated field trials to 0, 4, 6, and 8 tons per acre. So this is the layout of the demonstration portion of it. You can see they're just long one acre parcels, and that's how we laid, we have a control here, 35 feet wide and, a couple 100 feet long. And then we go into live soils to the rate of 2, Indian head 2, live soils 4, Indian head 4, and all the way to 10 tons per acre. And and we took drone imagery, we collected soil moisture data, we evaluated soil health. But again, this was a demonstration trial that we did run for 2 years, trying to figure out if we compounded we applied the same rates of compost each year, and we did it for 2 years in a row. Now, this is what we added to the project this year, which was significant, right? Because now we're actually able to do statistics on whether or not we're actually seeing differences. So this is the layout of our parcels. These parcels, each parcel is 30 by 30, separated by 5-foot spacing. The white, you can see the pictures here. The white represents 0 tons per acre. We didn't add any compost in those parcels. The orange, we added 4 tons per acre. The green, we added 6 tons per acre, and the blue, we added 8 tons per acre. And that is basically just a random control block design. Okay, so we put it over the course of, that didn't even take up an entire acre because those are 30 by 30 foot parcels. Collected moisture sensor, routine soil and tissue, drone imagery. Again, we did soil health on these plots, and we summarized the results, sent them to DEP, VAX. Here's a video of how we applied compost and how they apply compost in a commercial way. This is for the large scale plots. The demonstration trials is how we put the compost across the large scale acre plots. And obviously you can change the rates with that machine, put out more or less. This was a 2 ton per acre demonstration of in the video. So you can see that it's not really a lot of coverage. That's just 2 tons per acre. Now, what we had to do in the replicated plots was that we had to lay that by hand. Okay, so we had to weigh out the buckets, make sure we had the poundage, and make sure that we spread the buckets over those replicated plots. And you can see the orange is the 4 tons, the green is the 6 tons, the blue is the 8 tons, and you can see it a lot better when we show you in the drone footages. Now, we took compost analysis at the beginning, and we did it for year 1 and year 2. And I just think it's important that we notice that compost is not always the same. Okay, so even though we use the same company to get the compost in year 1, the moisture, look at the moisture and how it changes, right? I mean, it's wetter, it's drier, it's, and moisture is going to change how accessible the nutrients are, how much actual nutrients are available to the plant. So the moisture is different in the life soils, 45% moisture in the first year, 58% in the second year. And then look at the nitrogen percent. That's on a dry matter basis. So the percent of nitrogen has nothing. On a dry matter basis, it's just you're removing the variable of moisture. So you're just figuring out exactly what percentage of nitrogen is in that dry matter. If you dry it completely, what percent? Well, you can look and see 2%, 2.1% versus 1.68 for life soils. And then for Indian head, the nitrogen percent also went down from 1.66 to 1.14. Now, the available nutrient nitrogen that's available to the actual plant in pounds per ton is going to be a calculated value based on the moisture of the material and based on the actual percentage of a dry matter basis of that nitrogen. So you can see in year 1, the available nitrogen to the material, to the sod was 9 pounds per ton, whereas the rate in year 2 was 5.68, even though it only changed slightly in the percentages. And then you can also see look at the available nitrogen, for example, the 5.68 in year 2 of live soils compared to 5.44 in year 2 of Indian head, but their percentages are slightly different, but look at the differences in their moisture. So my point here is that those things change. Even though the percentages of the P2O5 phosphate changed, they were exactly the same in terms of availability in pounds per ton because of the changes in moisture. So my point here is that the pounds per ton is a calculated value. So in order to figure out that calculated value or that actual availability to the crop, you definitely have to understand moisture content and understand percentage of that nutrient in the compost itself on a dry matter basis, or you need to understand it on a fresh matter. When you combine dry matter basis and moisture, you understand the nutrient percentage on a fresh matter basis. That was a pre-question. This is the project timeline. You can see that we spread the compost application mechanically, and then we by hand in the research plots. We did soil tissue sampling, drone photography, soil moisture sampling throughout the whole year of the grant. And what you need to notice here is that there were NPK applications. These were done by the producer. He did not stop his normal fertilizer production. So we had to consider those as variables. This is some of our results. Okay, from our replicated plot, you can see that, remember, the 0 is the 0 rate. So you can see as you just compare, this is with the normalized difference red edge. That's oftentimes considered the health index because that actually reads the chlorophyll that's on the ground from a drone. So that's the NDRE is I don't speak drone language, but that is a very good indicator of health. So this is the 1122 222 is just a ortho, right? It's just a mosaic. There's no layer on that. And you can see the orange has a little bit lighter of darkness, right? Because that's 4 tons per acre. And then the blue is the darkest because that's the 8 tons per acre. And so you really can see that we effectively, really from a bird's eye view, that we effectively spread that compost in a way that showed some differentiation. And then you lay the red edge over it, or the NDRE, and you can see the red actually is an indication of not very healthy. The green is very healthy because, again, it's measuring chlorophyll. So without, any compost, you can see the red sticking out. Now, what I want to show you here is the last drone footage. I don't want to go through the entire project, but at the end of the project, June, what are we seeing here? We are not able to look at and compare the zero rate to the zero rate, that there's more red, maybe slightly more red. But what we're seeing is these green strips kind of running through all of the plots. So there's not a lot of differentiation that we were able to statistically say, hey, this is different based on our rates. And really what we're seeing here is an influence of fertilizer uptake, not compost. We spent a lot of money doing soil health testing. I think this was about $1,500, maybe $1,800 of the project, just doing soil health. And we did that on the kind of in the original baseline. And then we did it at the end, right? Because this soil health test, I think it's about $65 a sample. Unfortunately, even in the different blocks, look at all the variability. The organic matter and the soil health really should be the same in those initial blocks before we add compost, but they weren't the same. We ranged from 0.39 to 1% organic matter, and these soil health scores, they're not the same. So when you have so much variability at the very beginning in your plots, it's impossible to really come up with statistical differences at the end, which is unfortunate, but this is how it played out. Okay, so our organic matter for 0 or 4 or 6 or 8 tons, even though it slightly went up in percent, we've got 0.7 or 0.69 here at 0, and we go up to 0.75, statistically based on the variability in the very beginning, those are not different. So we can't document that we have more organic matter, even though you see the trend going up as the increase of that. And the same thing with the soil health scores. Even though our highest averages were at the 8 tons per acre, we couldn't differentiate that statistically. Soil nutrients over time. No, you cannot read this table. Table is to say we did a shit ton of and that's no pun intended on that, of analysis to figure out, are there different nutrients based on the different compost rates? And the only one that we could find of all of the evaluations we did in statistical analysis, and this is over the entire project, averaging these soil nutrients, because we did a baseline sample before the compost, and then we sampled 4 separate times following that through the project. And so the only one that over time of the entire project that was statistically different would be the 8 tons per acre, and that would be phosphorus in terms of pounds per acre. And you can see those 0, 4, and 6. And this may have been the influence of fertilizer. It may have been the influence of compost. It's hard to say. And then the potassium during the first sampling event was significantly different, and it did positively increase with the compost rate, but we did not see that throughout the project. By the end of the project, that potassium had pretty much leveled off, and we didn't see any statistical differences. Now, tissue, different story. We did not see any statistical differences in the phosphorus in the tissue samples. Okay, what we did see a statistical difference in was the percent of nitrogen in the tissue. And again, because this really doesn't make sense, at 0 and 8 are the same as 6, and then the 4 ton is less. So really, because that's not really making a lot of sense of why there would be more nutrients, more nitrogen at the 0 and 8 ton compared to the 4, we're kind of just saying, look, that's an interference. The nitrogen, the percent of nitrogen is really an influence of that producer adding the fertilizer to the project or to the project area that we just didn't have control over. And then I did want to point out that the zinc, iron, and copper during the first sampling event were significantly different and did positively increase with compost rates as compost rates went up. But again, by the end of the project, we couldn't discern any statistical differences there. So what are the conclusions and recommendations? Basically, replicated plots showed no statistical differences in any of the soil health parameters at different rates of compost. However, as I showed in the graphs, the organic matter and the soil health scores showed positive increases with increasing compost rates. Soil P concentrations were statistically different. They were higher at an 8 tons per acre rate compared to 0, 4, and 6 tons per acre. but this difference was not evident in the tissue concentrations that were, of course, collected by side with the soil. And we do feel like fertilizer additions dominated the effects in regards to our drone imagery differences and the percent nitrogen in our tissue samples over the entire course of the project. And so our recommendation would be, let's do some replicated trials without the interference of fertilizer. And so that's what Tater Farms has done. I am not working on this project with them. I am not receiving any more or did not apply for any more funding. I feel like we kind of answered some pertinent questions. And so I did not apply or do not intend to continue to work on this project. But Tater Farms felt that it was significant enough, the findings, to pursue cost share with the Water Management District, and that cost share has been approved in the board meeting in September 12, 2023. It's a year-long project. Now, the goal of this project is focused more on drone correlations. They want to determine if they can figure out nutrient requirements through the use of drone imagery. And so they're trying to come up with algorithms of what they can figure out on the drone filters and then exactly how much nutrients they need to add in terms of NPK. So I do think it's a worthwhile effort. It's just something that it's, I don't speak drone. This is not my forte. So the consultant is working with Tater Farms on this aspect. And during the year one, they will all be fertilized at the same rates. And during year two, fertilizer rates will be variable based on the interpretation of the drone correlations. And their replicated plots are split up into no fertilizer, fertilizer only, and fertilizer and compost. So that's the project that's ongoing. That's the amount of money they were awarded in cost share. And I just want to thank FDACS for this opportunity. It's been a great 2-year project. I've really enjoyed it. I've learned a lot. Looking forward to the compost, presenting some of this down at the compost consortium that we're having down at GREC in March. And if there are any questions, I don't know if there's time. I won't, but there you go.